Hello students, these are the notes that I gave on Monday, January 4th in Enrichment. These are on the linear and quadratic function families. We are going to be talking about the parent functions and comparing the two in this video. So first, what is a parent function? When you think about the word parent, the parent is the most original, or you could think basic, plain function of the family. So you might think about your parents and thinking they're lame. They're not lame, but you have your parent, and then we will add to the parent different members of their family in the coming weeks. So today, let's look at the originals. So first we're going to look at linear. Linear, the parent function of the linear is f of x equals x. What this means is that each output is the same as its input. No matter what I put in, my output is going to be the same. So if I input, we want to try to look at some negative numbers and some positive numbers to see what's going on here and see what the shape of our graph is going to be. So what's happening when our inputs are negative, what happens when our input is 0, and what happens when our inputs are positive. But like I already said, every input, the output is going to be exactly the same. So -2 outputs -2, -1 outputs -1, 0 outputs 0, 1 outputs 1, and 2 outputs 2. There's nothing changing there. Now we're going to take these as ordered pairs and put them on our graph. So in our objective for today, if you were in class, you know that we said we were going to look at table of values, graphs, and verbal descriptions for each of these families. So let's move on to our graph. Starting at the origin, remember this is my x-axis, this is my y-axis, this is my positive direction, this is my negative direction for x, this is my positive direction for y, and this is my negative direction for y. So I'm going to plot these points. -2, 2 goes left 2 and down 2. -1, 1 goes left 1 and down 1. 0, 0, that is the origin. 1, 1 goes to the right 1 and up 1. And 2, 2 goes to the right 2 and up 2. So just like that. We see it goes up 1, over 1 every time when we look at the slope in between each point. So we're going to connect those clearly for its shape. Ooh, if I can spell. Clearly it makes a line. Okay, and we're going to put arrows at the end to say we only looked at some inputs, but this goes on forever. All right, so now going to some verbal descriptions. One way to describe this verbally or in words is with our domain and range. So remember, the domain is our x values or inputs. So looking at my x column, my inputs, I see that I have negatives, I have 0, and I have positives. And if we think about it, just to make sure, I could input fractions and I'll get that same fraction. I can input decimals. And so what this means is if I see negatives, 0, and positives, and I was able to get outputs for all of those, then my domain is all real numbers. If I can input all of those different types, then it's all real numbers. Next, I'm going to do the range. This is my y values or my outputs. Okay, looking at my y values or my outputs, I see that I also have negatives, I have 0, I have positives. So nothing has to be excluded. Remember a couple weeks ago we talked about predicting the domain, and in some cases we have to exclude or leave out certain numbers, but for our linear parent, everything works. All real numbers for both the domain and range. Because if we can input anything, that means we're going to output because the outputs are the same. Okay, some other things to know about a linear graph. A linear function has a constant slope. So as you move across, it has a constant slope. And you can think about this in there's a lot of different situations where we use a linear function, but one clear example is an hourly wage, which means you make the same amount of money per hour. Okay, so like a minimum wage or any job where you make the same amount, that would be represented with a linear function. Okay, so you want to make sure that you're taking notes on these yourself. Next, the next one we're going to look at today is the quadratic graph. And the way that it's different from a linear is that it has a changing slope. It's not the only graph with a changing slope, but in comparison to linear, it does have a changing slope. Our parent function is f of x equals x squared. Notice parent doesn't have anything added to it, doesn't have anything multiplied by it. It's just the x and what we do to that x. And what this means is we're going to multiply each input times itself, or we're going to square it. Multiply each input by itself. So in order to compare these two, we want to look at the exact same inputs and see, do we get the same outputs as linear, or do we get something different? And as you can probably guess, we're going to get something different. So to input into this function, for example, if I input -2, that's going to be -2 squared, which is the same thing as -2 times -2, which equals +4. So my output is +4, and you can use a calculator anytime you need it. -1 times -1, that's a +1. 0 squared, or 0 times 0, that's 0. 1 times 1, 1 squared, that's 1. And finally 2 squared, 2 times 2 is also 4. So it's kind of interesting. It kind of like goes up or goes down and then goes back up in the same way. And the -2 and the +2 output the same. That's because any negative times a negative is a positive, and obviously a positive times a positive is a positive. So let's take these ordered pairs now and put them on our coordinate plane. So we have our x and y axis again. So we have the point -2, 4. Starting at the origin, I'm going to go backwards 2, or to the left 2, and up 4. 1, 2, 3, 4. -1, 1, to the left 1, up 1. 0, 0, 1, 1, and 2, 4. So if you notice, here we had a line. Here we definitely don't have a line. If we connect these, they create a U shape. And specifically, this U shape is called a parabola. Okay, so that's one way that they're different. Looking at the domain, if we look at my x values again for this function, we see that again we have negatives, we have positive, or we have 0 and we have positive. So this is going to be all real numbers. And we show that on our graph by putting arrows at the end saying it's going to go forever in this direction and forever in that direction. This is my negative direction going that way, and that's my positive direction going that way. Then for my range, my y values or my outputs, I want to look at this column. Here, you're probably being like, oh, wait, there's no negative numbers. I have 0 and I have positives, but I don't have any negatives. And that is true. That's because every negative times itself is just going to output a positive. And so you will never plug in any number into this function and get out a negative. So what does that mean for our range or all of our possible outputs? This is going to be all numbers that are 0 or greater. Okay, so we have a limit. We don't do any negatives for our domain. We have or our range. On this one we have a restriction. Some examples of how this is used. Roller coasters follow this shape. If you think about it, you start at the top of the roller coaster, you go down, woo, then you tick, 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 tick back up. And then if you continued doing these parabolas, connecting them, you would have a roller coaster shape. Another way is rockets. So a rocket could start here, go up, come back down, and then pretty much any like basketball, football, any soccer ball, any bouncy ball that you bounce on the ground is going to take this shape, as well as throwing or shooting a basketball, throwing a football, throwing a baseball, hitting a baseball. All of those are going to take this some U shape like this. It's going to go up and then it's going to reach its highest point. It's going to come back down, or it's going to start high, reach its lowest point, and go back up. All of these different types and many more can be used. You can use a quadratic function to represent them. All right, that wraps up our linear and quadratic conversation. And now you should be able to do the quizzes from today to practice this information.